Today we're going to be looking at the properties of radicals. So we're going to look at what happens when we add, subtract, multiply, and divide our radicals, our roots. So first, if we look at when we multiply, the rule for multiplying is as follows. If you have the nth root of a times b, all of that underneath your root, that is equal to the nth root of a times the nth root of b. The opposite is also true, so the nth root of a times the nth root of b, if they have the same index, you can multiply their insides, and that's equal to the nth root of a times b. Sometimes you'll want to split up the inside, so that way you can take the nth root of each term, or you'll multiply them together so you can get the nth root overall. So if we look at an example, such as the cube root of 12 times the cube root of 18. We don't know what the cube root of 12 is, nor do you know what the cube root of 18 is, so we're going to manipulate this in order to see if it helps us solve the problem. So since they have the same index, we can multiply their insides. 12 times 18 is 216. Well, now we're going to say that we need to see if we can find the cube root of 216. 6 times 6 times 6 is equal to 216, so the cube root of 216 is 6. That's an answer we couldn't come about if we had them separated, but once we multiplied, we could come up with that answer. Division works the same way, so if we look at division of radicals, that is the nth root of a over b is equal to the nth root of a divided by the nth root of b. So an example of this would be if we had the fourth root of 80 divided by the fourth root of 5. We don't know the fourth root of 80, nor do we know the fourth root of 5, so if we put them together, we get the fourth root of 80 divided by 5. We can simplify that. We know that 80 divided by 5 is 16, and we know that the fourth root of 16 is 2, so we get an answer of 2. So again, you see how manipulating that sometimes makes it an easier problem to solve. Adding and subtracting have a couple different rules. So to add or subtract, they have the same two rules. The first rule is they must have the same index, that's the little number squished in there, and radicand, that's the number inside. So they have to have the same index and the same radicand in order to add them together, because you're just going to be adding or subtracting their coefficients. The second thing that you need to keep in mind is you're going to use a factor tree. If they don't have the same radicand, you're going to factor tree it to simplify. But instead of when we did square roots, we were looking for pairs of number. We were looking for 2 2s or 2 3s or 2 4s. When we do these nth roots, you're looking for groups of the index. So if you're taking the third root, you're looking for 3 2s. Or if you're taking the fifth root, you'd be looking for 5 2s or 5 3s or 5 4s, something like that. You're looking for groups of however many the index. So we're going to say groups of index, if it's needed. Not every problem are you going to have to do that on. These first couple are just basic problems, so you're not going to have to do that. So if we look at the cube root of 4 plus 7 cube roots of 4, if you notice these have the same index, which is 3. They have the same radicand, which is 4. So we're just going to add them together. This is like saying I have 1 cube root of 4 plus 7 cube roots of 4. Means I will have 8 cube roots of 4. And that would be my answer. Subtraction. Much the same way, we're just going to be subtracting. So if we have 12 fourth roots of 2x to the 5th minus 3 fourth roots of 2x to the 5th, they both have an index of 4. They also both have a radicand of 2x to the 5th, so we can subtract them. If I have 12 fourth roots minus 3 fourth roots, that leaves me with 9 fourth roots of 2x to the 5th. So we had 12 of them, we took away 3 of them, so we have now we have 9 of them. So 9 fourth roots of 2x to the 5th. Let's do some more examples that are a little bit more challenging. So here's our more examples. First one we're going to do is if we have the square root of 3 over the square root of 75. We don't know the square root of 3, or do we know the square root of 75, so we're going to put it together, and we're going to have the square root of 3 over 75. That doesn't help us very much, but we know that 3 over 75 can reduce. Both 3 and 75 divide by 3, so that'd leave us this 1 over 25. We can then break it back up. So we know the square root of 3 over the square root of 75. We knew that we could put them together into one radical. Well, now we can break them back up into two radicals. So we're going to say the square root of 1 over the square root of 25. The square root of 1 is 1. The square root of 25 is 5. So we get our answer of 1/5. So if you notice, there's a lot of manipulating that happens here. You just have to kind of play around with the numbers and all the properties that you have until it works out to give you the answer that you need. So a second example we will work on is the third root of 54 plus the third root or the cube root of 2. If you notice, these do not have the same radicand. They both have an index of 3, but they don't have the same radicand. So this is where we're going to make our factor tree. We need to simplify this third root of 54, and we're going to see if we end up getting a third root of 2, and then we can add their coefficients. So 54 breaks down to 9 times 6. 9 is 3 times 3. 6 is 2 times 3. Because my index is a 3, so because this index is a 3, this tells me I want groups of 3. So I need 3 of the same number. In this situation, I happen to have 3 3s. So this 3, that 3, and that 3. We have a group of 3 of 3s. And so that's the number that's going to get to go out front. So since I have that grouping, that gets to come out front. Let me switch back to my red. So this pair of 3s, or triplet of 3s, comes out front. We're still left with the cube root. There's a 2 left over, so that's what goes on the inside. We're still adding to that a cube root of 2. So now we have the same index and the same radicand. So we factor treed. We looked for a group that had 3 of the same number because my index was 3. That group came out to the outside. Whatever's left over went on the inside. So I have 3 cube roots of 2 plus a cube root of 2, which will give me 4 cube roots of 2 as my final answer. The final problem we're going to do today is 12 fourth roots of 2. So we've got 12 fourth roots of 2 minus 7 fourth roots of 512. And we want to know what that equals. So here, if you notice, we do not have the same index. We have the same index, but we don't have the same radicand. So we're going to have to factor tree our 512. 512 breaks down to 4 times 128. 4 breaks down to 2 times 2. 128 breaks down to 2 times 64. 64 breaks down to 8 times 8. 8 breaks down to 4 times 2. This 4 goes to 2 times 2. Now we need to come over to this 8. So I'm looking, remember, once you split something up, cross it out, especially on these where you have a lot more numbers. So I'm finding anything else I can simplify. Over here I have this 8. So that goes to 4 times 2. Done with the 8. 4 goes to 2 times 2, and I'm done with the 4. Because my index is a 4, I'm looking for 4 of the same number. So if I look at this, I have 1, 2, 3, 4 2's right there. I have 1, 2, 3, 4 2's right there. And then I have 1, 2 left over. So as I do this problem, we still have this 12 fourth roots of 2. That's my original part, this front part, minus out front with my 7. I already have the 7. We've got a pair of 2's, a a group of 4 2s, another group of 4 2s. They just turn into 1 when they come to the outside. And then I have the 4th root of a 2 because I have a 2 left over. So now we have the same index of 4, the same radicand of 2, so we're going to simplify. So we have 12 4th roots of 2 minus 7 times 2 is 14 times 2 is 28 minus 28 4th roots of 2. 12 minus 28 would be negative 16 4th roots of 2. And that would be your final answer. So again, whatever that index is, that's the number that you need for each group in order for it to leave the radical. Pay attention to what you're doing, kind of work through these. You're going to have to manipulate things. You're going to have to rework them. You might have to take it apart, put it together, do all sorts of different things in order to arrive at the answer that you want or the answer that's going to work for you. You're going to keep going until things simplify and work together.